Hello students, welcome back to the online EGDL lectures. Last class we have done 3 problems under drawing number 4. You are left with 2 more which we will be completing in this video. All the 3 problems were done on a case where the line is inclined to both HP and VP. So what you have learned in those 3 problems is, when you are given the projections of a line, you have learned how to draw, how to find the true length and how to find the true inclinations. That was one case. Similarly, if you are given the true length of the line with the true inclinations, theta and phi, you have also learned how to draw the projections. In other words, how to get the top and front views. This is what we have learned. The problems on projection of straight lines is unique in nature. Each problem is unique. Okay. So I can't give it in writing what procedure has to be followed solving a problem. Okay. It comes by practice. Maybe this is the reason why students don't prefer to attempt a problem on projection of straight lines in the exam. There are few students who like projection of straight lines. They do attempt a problem on projection of straight lines. So let me finish these 2 problems and then we will be moving to projection of planes. Okay, let us see what is this problem. This is problem number 4, in fact, in drawing number 4. As per the question bank, it is 2.2.4. The reference number from the VT primer is 14. Let me read out the problem for you. There is a point B of line AB which is on HP. So B is on HP. In other words, B dash should lie on XY. The top view of the line makes an angle of 30 degrees with XY. So this is nothing but the angle beta. It is the inclination of the top view with XY. So you are given beta as 30 degrees. And the top view is 80 mm. The length of the top view is also given. Okay. So let me write down. The top view is given as 80 mm and its inclination is also given, which we take as beta, 30 degrees. Okay. Then point A is on VP. That means A I have to keep on XY and it is 50 mm above HP. So the position of the point A is given. It's on VP and 50 mm above HP. With that information, you are asked to draw the top and front views and obtain the true length and also true inclinations. This is the problem. Okay. It's slightly difficult, I would say, compared to the last 3 problems. Let us solve it. XY line in first angle projection. Now how to solve? How to start? You are given the position of the point A with reference to VP as well as HP. So I will start with that. A is on VP. So I will put the top view of A here. And it is 50 mm above HP. That also I can mark. This distance is 50. Now you are given the top view as 80 mm and its angle is also given. I can draw that. I can draw the top view straight away. The length is 80 mm and the angle is 30 degrees. This is B. I think I will just increase the angle a little bit. Okay. So this is top view. So I call this point as B. Let me dimension it. This is 80 mm. Then there is some other information left out. It is the first one. Point B is on HP. This is the top view of B. It says that the point B is on HP. So if I draw a projector from B, B dash should lie on XY. B is on HP. So this is the front view of A. This is the front view of B. When I connect them, I get its front view of the line AB. This is what you are given in the problem. Okay. The order of the problem is slightly different from what I have followed. Okay. Point B is on HP. I followed as the last step. Okay. To get the projections. I started by taking the point A on VP because you are given the length of the top view and its angle. Okay. So I started by taking the point A on VP. Its other end position is also given 50 mm above HP. After that, what did I do? I have drawn the top view itself straight away, taking this angle as 30 degrees and the length as 80 mm. So I have drawn the top view with the given length. I got the point B, so I can draw the locus of B here. While doing the rotation, normally we keep the left end fixed and we move the right end only. That means point A is fixed here and position of point B we move to get the true length and other things. Okay. So this is the locus of B in the top view, and in the front view this is the locus. XY line itself is the locus of B because B is lying on HP. It's always better as soon as you get point B to draw its locus. That will make the things easy for you. Okay, let us see what is to be found now. You are asked to find the true length. You know how to find the true length. This is a case again where the line is inclined to both HP and VP because the top view is inclined to XY, front view is also inclined to XY. So what is that you do to get the true length? We have to make one of the views parallel to XY. Okay. So I will make the front view parallel to XY now. So what do? Normally we change the position of B, fixing A. So I draw a line parallel to XY line from A dash. Take A dash as center and A dash B dash as radius. I make that line parallel to XY. So I draw an arc in this direction to make A dash B dash parallel to XY. Okay. So this length is equal to this length. In other words, the front view is made parallel to XY. Now, if the front view is parallel to XY, if I draw its projection, the top view should become true length. You know the true length principle. Okay. So B dash is moved to a new location B1 dash. So B also correspondingly moves to a new location and it can move only along the locus of B. Okay. So what do? Draw a projector from B1 dash onto the locus of B. And this you can call as B1. This is B1 dash, so this should be B1. That's it. If you connect A with B1, you get the true length. Is it not? And the true length will be drawn as a thin line, not thick line. That is the true length. So you can measure it and show the true length. Let me check what is true length. It's 95 mm. We should get the true length as 95. And you get the angle as well here. This is nothing but phi. The inclination of the line with VP, it should come to 25 degrees. So true length is obtained. The inclination of the line with VP is also obtained. What are you left with now? You are left with the angle theta. What is the inclination of the line with HP? I got the true length as 95 already. So I will draw the true length in the front view as well so that I get the angle theta. What do you do for that? Take A dash as center, 95 mm as radius. This is the true length. 95 mm as radius, cut the locus of B. Let us call this as B2 dash. Connect A dash with B2 dash, you get the angle theta. So this is also true length. True length is 95. Okay. So A dash is the center, 95 mm is the radius. You have drawn an arc to cut the locus of B. Whenever you are cutting, you are always cutting the locus. Please remember this. Okay. That's the reason why I have shown locus of B, locus of B. That's very important. So when you measure theta, it will come to 32 degrees. So these are the three things you are asked to find. One is the true length and the other two are the inclinations. Find the inclinations of the line with HP and VP. So let me write down what I got. True length I got as 95 mm. Theta is 32 degrees and phi is 25 degrees. This is what I obtained as the solution. Okay, the only doubt that you may get is the problem is not in order. Okay, so you may have a doubt of how to start. Okay, whether to start by taking B on HP. If you take B on HP and start, you can't draw anything. If you start by taking the point B on HP, you can't draw the front view. Nothing is given about the front view here. So the only important point that you should know in this problem is to start by taking A on XY. If you start by taking A on XY, you are able to draw the top view because its length and position are given. That's the only difficulty in this problem. Once you start with that, then it will go on. Okay. So that's about this problem. The other advantage that I have when I am using a video is I don't have to repeat the procedure once again to you, because if you want, you can go back and watch the video. Normally what I do in the class I normally repeat once for the students, but I don't have to do it now. If you want it, you can go back and listen to it again. Okay. So with that we complete this, and so you are left with just one problem in this drawing number 4. I'll come back to that. Okay, let's take the last problem, problem number 5 of drawing number 4. This problem is slightly complicated than all the other 4 problems that we have done so far, because it involves the side view of the line as well. So far we have drawn only the top and front views of the line. This particular problem involves the side view of the problem as well. Maybe that is the reason why this problem has been included under this drawing. Let us see how to do it. The problem goes like this. The problem number is 2.2.5 and the reference number from the VTU primer is 47. Okay. So this is R47. The problem goes like this. A straight line PQ 80 mm long. That means you are given the true length as 80. Appears to be a length of 50 mm. Appears to be means it is the apparent length. Appears to be a length of 50 mm and inclined at 30 degrees to XY line in its side view. So the length of the side view is given as 50 mm. And its angle is also given 30 degrees. There is no standard notation to represent the inclination of the side view, so I am not going to write it down here. 30 degrees is the inclination of the side view, that much I know with XY. Draw its projections when the end P is 15 mm above HP and 60 mm in front of VP. So you are given the position of the end P. Okay, but the position of the end Q is not given. The only information that is given is point Q is nearer to VP than P. So in the top view, when you draw the projections of P and Q, Q should be nearer to XY than P. Only that much is given. Okay. So this is what is given in the problem. You are given the position of point P. You are given the true length 80 mm. You are given the length of the side view and its angle as well. Okay, it is just mentioned the side view, whether it is left side view or right side view is not mentioned. So I prefer to take it on the right side. In other words, I am going to draw the left view in first angle projection. So you have to plan in such a way that you have sufficient space on the right side to draw the left view. So this is XY line. You are given the position of the point P. I can start by drawing its projections. Point P is 15 mm above HP, 60 mm in front of VP. 15 mm above, 60 mm in front of. So this is P dash and this is P. 15 and 60. Okay. Done. Nothing is given about point Q. No distance is given. Now I should move to the side view. Leave sufficient space here for drawing the top and front views, and then to draw the side view, you know how you have to draw x1 y1 line. So let me draw x1 y1 line here, x1 and y1 at some distance, but you should maintain some distance because I have to accommodate the top view here and front view here. I am going to draw the side view of the point P. This you know, we have done it in projection of points. If this is the top view and this is the front view of P, I know how to get its side view. How to get it? We draw a line inclined at 45 degrees at this intersection point, depending on where you have the top view. This is first angle projection I am following. So the top view always will be found below XY. So I will draw a 45 degree line below XY. This is 45 degrees. Now what do? You have to draw the locus of P to intersect this 45 degree line at a point. There you will draw a perpendicular, and then will come from the front view and get its side view. That is the procedure, we know that. So let me obtain the profile view of point P. This direction is the point, then this is the direction in which the perpendicular is drawn, and now the locus of P in the front view, this is P double dash. So I got the profile view of point P. Okay. So now I can draw the profile view of the line PQ. Okay. The length is given as 50 mm. Length of the side view is 50 and its angle is 30 degrees. So let me draw the side view inclined at 30 degrees to XY. Now the question is, if this is point P, there are four possibilities of drawing the line inclined at 30 degrees. Either I can draw it like this, inclined at 30 degrees to XY. I can draw like this. I can draw like this. I can draw like this, inclined at 30 degrees. There are four possibilities. Now these two possibilities are ruled out. I will tell you the reason why. Okay, drawing the side view towards right is ruled out because there is a point what is given here that the point Q is nearer to VP than P. Because of that reason, once I complete, I'll be able to explain why it was not taken to the right. But when you take it to the left, either you can take it downwards or you can take it upwards. Both are accepted. Any way you can take. So you are going to draw a line inclined at 30 degrees and equal to 50 mm here. I am drawing it above. This is Q double dash. This angle is 30 degrees and this length is 50. So I have drawn the side view of the line PQ with the given data. So this is Q double dash, okay, profile view. Now your aim is to locate Q and Q dash from this. You know, when you have the top and front views of a point, you know how to get the profile view. Now the profile view is there readily with you. From that you have to get Q and Q dash. That means the top view of Q and front view of Q. If you have closely watched in the problem that you have done for this profile view, Q double dash and Q dash will lie along the same line which is parallel to XY line. Okay, that you must have observed. In other words, this is the locus of Q in the front view. In other words, the point Q dash should lie on this. So I could get the locus of Q in the front view. Similarly, I want to get its locus in the top view. What is the procedure? We adopt the reverse procedure of getting the profile view. Profile view is there. Now I want to get the top view. So I will draw a line perpendicular to XY. It will intersect XY. It will intersect 45 degrees at some point. I will come back in this direction. Now this should be the locus of Q in top view. Okay, please follow carefully. Okay, you got the profile view here. From there I could draw the locus of Q in the front view, because Q dash and Q double dash will always lie on a line which is parallel to XY line. Maybe you can refer back to the problem on the side view in projection of points and look. And to get the locus of Q in the top view, what did I do? I put a perpendicular projector onto 45 degree line, and then I have come back. So my Q should lie on this line in the top view. For that, what information can you use? You are given the true length as 80. Okay, so I will draw the true length of PQ in the top view now. P as center, 80 mm as radius. Cut this. This is the true length, so I will call it as Q1. It's not Q, it is going to be Q1. So this is true length. It should be a light line. And let me dimension this. This is given as 80 mm. Yes, now the profile view is done with. You are done with the profile view. I don't have to go there again. You have the true length here. Because the top view is true length, its front view should be parallel to XY as per true length principle. Okay, so draw a projector from here onto, this is P dash. Make the front view parallel to XY. So this is Q dash. Okay, so the true length principle is satisfied. Because the top view is true length, the front view is parallel to XY. So thereby I got the length of the front view. Using the true length principle, you got the length of the front view. But this is not the position of Q. It should lie on this line. So what do? Using the same length, you should have the same length, but Q should lie on this locus. So take P dash as center, P dash Q dash as radius, draw an arc to cut the locus of Q. That will be Q dash. This should be Q1 dash. So this is the front view of PQ. This should be a dark line. Is that understood? If Q dash is here, Q should lie on the locus of Q in the top view. So I can draw a projector. Wherever my projector intersects the locus, that should be Q, and this is the top view. Top view should be dark. So slightly complicated problem because the side view is involved. Normally problems of this nature are not asked in the exam, but you should learn. When you are learning projection of straight lines, you should learn when there is a problem given in the VTU primer. Okay. So step by step you do when you do it in your sketchbook. Okay, step by step you can pause your video, do that, and then continue your video and implement it. Okay, it's a slightly difficult problem, I accept, but do it. Try to do it. Last semester I have seen some of the faculty have not done this problem in the class, but I would prefer you to do it in the sketchbook. Okay. So let us see now, the projections are done. Let us see what you are asked now. You are asked to determine the true and apparent angles. The angles are already there here, some of the angles. This is true length, so this should be angle phi. This is apparent length, so this should be angle beta. This is also apparent length, this should be angle alpha. Inclination of the front view is alpha, inclination of the top view is beta. The only angle that is required is theta now, inclination of the true length with HP. You know the true length, which is 80. So take P dash as center, 80 mm as radius, cut this. This will be Q2 dash. Q1 dash is already there. So this is the true length and this is the angle theta. The construction itself appears a little complicated as soon as the problem is done with, okay, but step by step if you follow, there is no difficulty. Okay, the only thing that what you have applied is your knowledge of how to get the side view of a point and how to come back from the side view to get the top and front view also you have experienced in this problem. Let me give you the angles. There are 4 angles which you are asked to find. Theta is 18 degrees, phi is 33 degrees, alpha is 22 degrees, and beta is 35 degrees. These are the 4 angles which you need to find. This is definitely a challenging problem to all of you. So please follow carefully. Please, maybe, yeah, as I told you, pause your video. Maybe you can pause it 2 to 3 times by the time you complete this problem. Okay. So with that, we finish the projection of straight lines. That is drawing number 4. Drawing number 5 is assignment to you. So we will start with drawing number 6 when I come back with the next video.